Lab 1, Charge Tape. The purpose of this lab is to determine the interactions of charged pieces of tape and the amount of excess charge on them. Key concepts to analyzing this lab are Coulomb's law and Newton's laws. The main results that were found are that charge on a piece of tape is 5.41 times 10 to the negative 8th coulombs, while the corresponding electrons lost was 3.38 times 10 to the 11th electrons. Fundamental principles that are important to this lab are Coulomb's law, which quantifies the electric force between charges, and Newton's second law, which states that force is proportional to mass and acceleration. This is important because at static equilibrium, we see that net force equals 0. The initial conditions of this lab were that tape mass was found to weigh 0.2 grams, while the tape length was 0.2 meters, and the tape width was about 0.02 meters. We also found that tape was positively charged because it was attracted to negative items. The system is tape B, while the surroundings are tape A and everything else. And the procedure is that the tape A and B were charged, tape B was suspended, while tape A was brought underneath tape B until tape B floated. For our analysis, the first step is to find gravitational force, which was found to be about 2 times 10 to the negative 3rd newtons. Electric force, we can find that it is equivalent to gravitational force because we're in static equilibrium, and therefore we can solve for the charge on tape B, which was found to be 5.41 times 10 to the negative 8th coulombs. The electrons lost can be found by dividing by the charge of electrons, which was determined to be 3.38 times 10 to the negative 3.38 times 10 to the 11th electrons. The electrons lost per atom can be found by dividing the number of electrons by the number of atoms, which is found to be 8.72 times 10 to the negative 7th electrons per atom. We can model this using a computational model which represents the ideal scenario of physics, where we can model each tape as point charges. As you can see, our observed calculations and our computational model have very similar numbers, which indicates a low error. Some assumptions that were made was that air resistance was ignored, tape was approximated as point charges, equal charges were on both tapes, while there were evenly distributed charges. Some potential sources of error are loss of charge due to handling or the environment, uneven charge distribution, not being in static equilibrium, or environmental disturbances. If electrons and protons have had opposite charges, our observations would not change and the tape would behave the same. However, the observed charges would have opposite signs. It's important to handle tape as little as possible because it loses charge when coming into contact with other surfaces. This is not ideal for our experiment because then there would be a smaller electric force. Overall, we were able to find the charge on a piece of tape as this number, which corresponds to this many electrons lost, which had a low % error. Thank you for listening.